Hi, hello everyone. Myself varaince. I am from EC branch. I am studying in VVIT college. My roll number is 25BQ5A0410. Today I am going to present a seminar on movements and variance. In this seminar, I will explain the basic concepts of movements, types of movements, and their applications. I will also discuss the concept of variance and how is it is used to measure spread of data. Let's begin the concept. This is the definition of movement. Movement is a numerical measure to describe a certain properties of a random variable. They provide information about the location, spread, and shape of the probability distribution. The certain properties are spread, shape and location. Then let g of x be a real function of a random variable. P means variable such that g of x is equal to x power n for n values 0, 1, and so on infinite. The expected value of g of x is called the moment about the origin. It goes to the moment about the origin. This is the moment about the origin. This is the continuous formula. Mn is equal to minus infinity to infinity x power n f of x into x. This is the continuous equation. It goes to the discrete summation of n is equal to 1 summation of n is equal to 1 to infinity x power n into p of x. This is the discrete. They have special cases where the m naught is equal to integral of f of x into dx. m naught is equal to 1. That is the total probability. M1 is equal to minus infinity to x into f of x into dx is equal to mu. That is mean. M2 is equal to, this is the second central of movement. Like it is called also a variance. So next, this is the movement about the mean. That is the central movements. They have general formula for continuous. Un is equal to minus infinity to sorry okay. This is the special cases. mu1 is equal to 0. mu2 is equal to variance. Variance means this is the second central of the moment. That's why I can show you image. This is the first central moment. This is the second central moment. This is called the variance. So mu3 is equal to skewness. This is the third central movement. That's okay. The fourth central movement is called a Cortis's measure. Next, importance of movements. Describe the shape of probability distribution. Provide a measure of location, spread, skewness, and cortices. It helps to understanding the behavior of a random variable. The movements help. What is the help of movements means? It helps the how to behave the random variable or signals. Next, central movements. They have special cases where the n is equal to 0 always equal to 1. This is the 0th central moment where n is equal to 1 always equal to 0. This is the first central moment where n is equal to 2 equal variance means n is I will show you already. That is the second central moment. So 5 moments describes cuteness and cortices. Next I will go to the variance. Variance means variance measure the average squared deviation from the mean. This is the formula. This is the general formula. Variance of x is equal to e of x minus mu into square by mu square. This is the general formula. Why we use it means it quantities the spread of data around the mean. I can explain already this signal. This is the standard deviation. Standard deviation is the square root of a variance. It have a same unit of the data. Physically meaningful means show how far values typically divide from the mean. Means this is the signal. The signal how to behave the my point is the signal how to deviate the mean. That is called the physical mean. It's called the deviation of mean. The mean means mean means mu naught is equal to 1. That is the mean. Let's go to the properties of moments. The moments exist only of integral is a finite. That is linearity. This is the linearity property. E of ax plus b is equal to a into e of x plus b. This formula is same as to the multiplication of a multiplication with a constant. Next, the relation central moment can be derived from a raw moments. The next point, additivity for independent variables. Those are properties. The last property is standardization. The central moments can be scaled by mu n. Next, I will go to the properties of variance. Property of variance means variance is always greater than or equal to 0. Variance of constant is equal to 0. Next property, variance of ax. A means this is the constant and multiplying with x, multiplying with a random variable. So variance of ax is equal to a square into variance of x. Next, variance of x plus c is equal to variance of x, because variance of constant is equal to 0. So variance of x plus c is equal to variance of x. For independent variables where x and y are independent variables, then variance of x plus y is equal to variance of x plus variance of xy. This is also can also called as this is in the form of distribution property. Yeah, distribution property. For general case, variance of x plus y, variance of x plus variance of y plus 2 combination of x plus y. Next, I will go to the Advantages of variance and standard deviation. It provides clear measure of a spread in data, useful in probability statistics and data science, basics for hypothesis testing and confidence intervals. It helps compare variability across the different data sets. Next, application of a moments. They have some applications. They are in statistics. Moments is used in statistics for describing distributions in financial management, risk and volatility analysis. In engineering purpose, error analysis, reliability studies. In machine learning, future extraction and destruction of analysis. Next, physical significance. It is a variance of show the stability of a system. Example, student exam marks the spread. Example, stock market validity. These are three examples. Mission manufacturing errors. Next, we go to the conclusion. What are the movements are fundamental in describing probability distribution, variance and standard deviation method spread. Higher movements explain shape of skewness and cortices. Skewness means this is the third central movement. Cortices means this is the fourth central movement. Applications of span across the science and engineering and finance. This is the whole concept. Thank you.